Hello, in this video I'll be showing you depth first search and breadth first search, and I'll be implementing the two tree searching algorithms in JavaScript. So first, to start off with a high-level overview of what is depth first search. Basically, excuse me, given a tree, a graph, and given a target, let's say target equals 5, we want to search the graph and see if 5 exists or not. So this graph, this tree may not necessarily be of any ordering. It may not be a binary tree. It can be any tree. So in the depth first search algorithm, we actually go and we visit each of the child nodes, okay, first, and then propagate the search result upwards. So we go child first. So this would actually be the exact direction that it goes. First it'll go here, and then it'll go to the first leaf node in the right subtree, and then it will go to the third. So it will go all the way down before going up. Okay. So in breadth first search, things are a little bit different. We actually go level by level. And what that means is we start at the top level node, the root node, and then we search the second level node, second level of the graph, and then we search the child node in that same order, okay, and etc. So if this was a graph, let's say 1, 2, 3, 4, 5, 6, 7, we'll be looking at each level at a time. So we'll be looking at 1, and here we'll be looking at 2 and 3, and here we'll be looking at 3, 4, 6, and 7. Okay, so we're going level by level. This breadth first search algorithm can be implemented using a queue where where I'll show you in a moment. And the depth first search algorithm uses recursion because we recurse into each of the child subtrees. Okay, so let's go ahead and implement depth first search. I'm going to use Node.js. So depth first search. So first of all, we need to start off with a node, which will first initialize a root node. Okay, so class node constructor. We're going to have a value, and we're going to have so basically we just need to put in the value in the constructor. We're not going to initialize any children in the node class. So this video is going to be helpful because I'm going to basically make a bare bones tree and then add values and implement the algorithm, then test using some test cases. So this dot value equals the value that we bring in, and we're going to have a method that will help by adding a child. So add child, and then this will take in some node, and then this dot children dot push node. Okay, and just to test it out, let's say const root equals new node, and we're going to give it 5, and then we're going to do root dot add child, and then we're going to pass in so inline instantiation 6. Okay, and let's see if we can just console.log the root here. So node depth for search. So push of undefined, so probably means that we need to have a child here. So let children equals some array. Okay, let's give that a shot. So I need to double check JavaScript classes. Class. This dot height. Okay. So realize probably I have to do children inside the constructor. Right, that's what the constructor is good for. This dot children is equal to empty array. Okay, so this dot children node. So we have our node with the value and some children. Okay, so I want to build out the exact same tree that I made in this graph here. So the left subtree, so the first item that I'm going to push in will be a 2, and then we're going to push in a 4, and then 4 is going to have 2 children. So let's just try and replicate that. See here, so root, okay, and then const left will be a new node. 2 const right will be a new node 4, and then right, and then we're going to add the left child, and then we're going to add the right child. But before we do that, we need to add new node 5, and we need to add a new node 7. Okay, and this will be our tree, in which we'll need to implement depth first search, which will take in the root and the target. Okay, to do. So this is our tree semantically. Okay. And I just want to now implement depth first search algorithm, which, like I said, is implemented using recursion. So given a root and a target, we want to search the graph. So const node, we're gonna start off, let node is equal to root, and then for const child of node dot children, we're going to run depth first search on the child and pass in the target. And if this returns true, then we're going to return true, that we have found the target in the graph. Otherwise, it will exit the loop and will return false. So if we searched every single child and it's not there, then we're going to return false. Here we need to check that if node.value is equal to target, which is our base case, then we're going to return true. Okay, and this base case will run in each of the child nodes. So let's go here and test out depth first search on our root node. We're going to give a target 10 that does not exist in the graph. This should return false. And we want to console.log the results. Okay. And I'm going to copy this over and put in 7, which does exist. So we should get back false and true as intended. There we go. So that is the depth first search algorithm. And now to implement breadth first search, which will take in the exact same inputs, root and a target. The only difference here is that we're going to be using a queue. And this queue will basically keep track of all of the nodes that we need to visit at the current level. We're going to dequeue in JavaScript, shift over each array element inside the queue in a FIFO, first in, first out manner. And then we're going to push in the children nodes from the following height, from the next height in each loop iteration. And we're going to do all of this in a while loop, okay? But first of all, we're going to start off with a queue. So let queue, and we're going to start off with the root node. So while queue.length is greater than 0, then we're going to do the following things. So let current node, so let node equal to queue.shift. Now what this will do will just in a queue-like manner pop out the first element in the array. Okay, like I said, so in FIFO, first in, first out. And we're going to check right here, like a base case, if the node value is equal to the target, then we're going to return indicating that we have found what we were looking for. Otherwise, we're going to while q.length, we're going to q.shift, okay, and then we're going to push in the child nodes, okay. So q dot push node dot children So I'm just trying to confirm that at the first level we're going to have one node in this queue. When we run this, we're going to shift, so popping out the node, which is what we want, and then we're going to do the check. It's either going to return true or it's going to continue. Here we're going to push all of the children nodes, so we're going to expand that array, and we're going to push each and every element. Okay, and finally, if we do not find anything after the entire tree and queue are exhausted, we're going to return false. So now, like in depth first search, we're going to console log the same test cases just to verify. Depth first search, we're going to instead do breadth first search. 10 and 7, and it should respond with false and true accordingly. So there we go. That is depth first search and breadth first search implemented in JavaScript. Thank you.